what I really learned was the cat levels. Obviously, I didn't know about these cat levels in terms of thermal imaging and fog visibility. So apparently, if you are at cat 3, which is up to 300 meters, even thermal imaging systems don't help. So you need a cat 1 or a cat 2. I think cat 1 is 1.2 kilometers, and cat 2, I don't remember the exact figure. I think it's 600 and something. 600 meters or something is cat 2. My takeaway is like the shorter wavelengths even are like small gears. So the way to think about these things, right? The cooler, yes, I think people who know about thermal imaging know about uncooled and cooled detectors. But the way I saw it is like if it's a shorter wavelength, it's almost like a small gear, and the higher the resolution you want, means the higher is equivalent to a high speed. High speed means high energy. High energy means heat. Heat means cooling. So that's how I started thinking about long wave infrared and medium wave infrared. And then it started to click. I'm like, oh, that's why they talk about cryogenics. So for me, the reason I'm actually making this stupid video is because I wasn't even going for something about thermal imaging. All I wanted to read was the basics of SAR. And when you start asking the question about why SAR, and if you look at the way the author has written certain content, it's really beautifully written, because it makes you think about why is that the case. Because we keep talking about cloud cover and darkness. Now you have cloud-free environments. That's the first thing. So the obscurial is gone. The first obscurial is gone. And the second thing, when we talk about darkness, we're talking about night vision, thermal imaging systems. So darkness is out of the picture as well. But still, you have an issue of fog and rain. And it was a practical experience for me. It just was surprising that I instantly remembered this particular range of wavelength. And I was like, oh yeah, now it makes sense, because that's the value of SAR.